Okay, Coroneos are 100 integrals numbers 37. This question, we need to integrate dx over 3 sine square x plus 5 cosine square x. This is a pretty hard question. There are at least two different ways you can do this question. You can use the trigonometry identity form to manipulate the denominator, and then somehow we can use the t form and substitution to work out the answer. There's another slightly easier way to do this question, so we don't have to use the t form to do this question, is by dividing both the top and bottom of this fraction by cosine square. Okay, and once we divide it by cosine square, you should be able to see that fall into a reverse channel using the inverse trigonometry. So we'll start with this. We divide both the top and the bottom by cosine square. So that means the numerator, if we divide it by cosine square, so let's just write this one down first. Divided by cosine square x, divided by cosine square x. All right, and I'm just going to do step by step. All right, the numerator becomes 1 over cosine square x. Okay, the denominator becomes 3 tangent square x, because if you divide a sine by cosine, that gives you tangent. Okay, all right, and then plus 5, and then dx here. All right, so once we finish this, all right, the next step we do is we use the trig identity formula. 1 over cosine square on the numerator here becomes sec square. So we'll write down sec square over, okay, 3 tangent x. Let's put a square this time here. So hopefully that way you should be able to see what's going on. All right, now this is a reverse chain rule, okay, using the inverse trigonometry. So I'm just going to write a formula on this side, and so you should be able to see what's going on, why this is a reverse chain rule. Now, remember we know there's one formula here, if it's like 1 over x squared plus 1, and then dx, then we know this is the inverse trigonometry integration. So the answer will be inverse tangent x. Okay, so that should be quite easy to understand. All right, and then we can also change that one into the reverse chain rule. So if we have f dash x on the top over fx to the power of 2 plus 1 dx, then that gives us an inverse tangent fx. So this question, is very, very, very similar to this format here, except we have a 5 there, which is fine, and also we have a 3. That's also fine. We can deal with that. So this is not a big deal. All right, and then a derivative of tangent x, what's inside, is actually equal to sec square of the numerator. So if you look at the formula, that is the original function of x, and the derivative of that is on the numerator. So by knowing which formula we're using, then in this case here, all we have to do is try to manipulate this expression a little bit. All right, so we can integrate that using that reverse chain rule. All right, so instead of writing a 3 outside, as you can see there's a 3 here, I would like to put a 3 inside this bracket. So that gives you a square root of 3 tangent x, all right, entire bracket to the power of 2. Once you finish that, I also want to write down plus square root of 5 and square, okay, because that is part of the formula later on that we're going to use. All right, and then the numerator is sec square x and dx. Okay, now we start to differentiate what's inside. All right, that gives us a square root of 3 sec square, but we only have a sec square on the numerator. So all we need to do is we need to add square root of 3 there. And outside, we just change that into 1 over square root of 3 to balance it out, all right, to cancel them out. Now we should be able to just apply the reverse chain rule formula. That gives you 1 over square root of 3, okay? And then we should be able to just do the question quite easy. And then times by 1 over square root of 5, that's just the formula. Tangent, okay, inverse, okay? And then square root of 3 over square root of 5. Tangent x, okay, plus c. All right, so eventually that gives you 1 over square root of 15 tangent inverse square root of 3 over square root of 5 tangent x plus c. And we should be able to just leave the answer like this. Okay, so it's a pretty interesting question, and the very first step is be able to change that expression here into this expression and realize this is using one of the reverse chain rule formula to integrate. Otherwise, you probably need to use the trig identity formula to manipulate the denominator and then using the t formula to actually solve this question there. Okay, thanks for watching.